Yeah. So it was
Well,
a
I hope you enjoy
successful trip.
I hope you enjoy the play of the Yankees.
Oh, they lost today, but man, they've been on a tear.
Are we
So
live streaming, Dale?
We're live.
Alrighty. Hey, welcome to this meeting of the Warren Astronomical Society. I'm Bob Trimble, your first vice president, filling in for Diane Hall. Diane Hall's president's report. She says the Cranbrook meeting was a success. Thanks to everyone who came out. Great to be in the auditorium again. A live meeting was energizing, and it was wonderful to see members who haven't been able to participate online. Macomb meetings are tentatively set to resume in September, barring a new surge of COVID, monkeypox, or whatever. Monkeypox? Thanks to everyone who signed up for the Cranbrook Lunar Eclipse event, even though it was sadly canceled. And we're putting out feelers for in-person discussion groups. Please contact Jeff McLeod. Everybody should have received a mailing on that. I did get a couple responses on that. People asking like how many people usually show up and that kind of stuff. But we're looking for somebody to host a discussion group next week sometime. First vice president report myself. I've got Deirdre Kelligan. She's going to be she's an artist and she works she blogs for the Vatican Observatory Foundation. She does a lot of stuff with children, so it's going to be very good to see what she does, astronomical sketching. I just filled in tonight, Dale, a whole bunch of the short presentations. I'm going to be doing a long series covering the decadal survey, and I'm going to be doing an overview and then covering some specific missions in that from now on throughout November. I'm going to be writing them for the Vatican Observatory Foundation anyway, so I'll be using that information. Treasure report, Adrian.
well, short and sweet. We are well over the 30,000 mark thanks to the donation from John Rood. I know we've picked up at least one new member and we've had a couple of renewals. The Astronomical League deadline is coming up next month for turning in Astronomical League dues for the 2022-2023 season, if you will. So those of you who would like to become Astronomical League members, it's $7.50 if you haven't already paid that with your dues renewal. The other thing for reimbursements, for those who spend money on behalf of the Warren Astronomical Society, and if you'd like to be reimbursed, simply send me a receipt of your purchase, what it was used for, and I have found that I can reimburse you online. I can send a check to you online, which I'm going to start doing. I can also send you from our PayPal account if there's enough money in that PayPal account to send you a reimbursement, or if you use Zelle. So those are the three ways we have so far to reimbursements. I personally have Cash App. I don't know if I will be incorporating that into our ability to reimburse, or connecting that to any of our accounts. I'm a little wary of doing that because there are some fees there. But I'm sticking with just those three options. And other than that, yes, we were at Cranbrook. We did pick up a couple of membership renewals there, which I did finally process after a couple of weeks. So far, that is it for Treasurer report. If there's any questions, of course, you can send email to treasurer@warrenastro.org.
Thank you, Adrian.
And back to you, Bob.
Secretary report, Mark.
Good evening, everyone. I have nothing to report, so take it away, Bob.
Well, that was way too easy. Come on. Outreach, is Kevin here? I see Kevin. Well, unfortunately, our event at Cranbrook was canceled due to the total lunar overcast and rain, and hopefully, I'm sure Cranbrook will be asking for more help in the future. Publications, Dale.
Actually, Bob, I wanted to jump in
Yes.
because of my unique vantage point happening to be out west, I was able to share my eclipse picture with a couple of global outreach opportunities. Global Star Party,
Nice.
which a fellow RASCA member posted it during their global B images. It's one of the images shown in a Global Star Party. Also, there was a global effort done by an Italian, Gianluca Massi, who I'd worked with before, and he did a live stream of images. So we did manage to do outreach after all. It was just kind of a unique and unexpected direction.
Distributed, yeah. Yeah, I had rain here. I got up early in the morning and I heard just on the skylight. I'm like, yeah, great. Sigh. So publications, Dale.
Okay, well, all the reports that are getting glossed over very quickly here are all found in the WASP, which is online. And that's my report.
Alrighty. Special interest group. I'm going to do solar at the end here. Let's go hands on. Riyadh.
Yeah, hi. Well, first, of course, the observatory report.
Oh,
Last
why is that on here?
meeting was in April 23rd. It was mostly hazy, kind of cloudy and hazy sky, but a few bright double stars poked through the clouds, and we were able to look at them with the 10-inch Dobsonian, and also we used an 8-inch Celestron that was there. Roughly, we had 35 people attending, including some scouts and their leaders. And we closed the session at just a little after 11 o'clock. Next open house is May 28th, starting 7:30. And for the other report in terms of the hands-on group, of course, as usual, I'll have my list of objects to look at. In addition to that, this time we have a couple of the pieces of equipment that I just purchased for Stargate. One of them is a super wide angle binoculars. I think it's part of the lecture today, as it will include that as well. And also the ZWO atmospheric dispersion corrector. So hopefully, if it's clear, we'll have a lot of stuff to experiment with and to look through. Thank you.
Thank you, Riyadh. History, Dale. Any history to report? History group.
Well, I was all set to report at the Cranbrook meeting, but then couldn't get through because of the setup we had. So I'll get that now. In the club 10 years ago, 2012, at the board's May meeting, the board had settled on a choice for the new telescope, an 8-inch f12 refractor telescope from D&G Optical. We also had members catch the May 20th annular eclipse in Canaryville, Utah, and you can read their report in the June 2012 issue of the WASP. And then 20 years ago, Larry Kalinowski noted that Doug and Robin Bach were awarded lifetime memberships, and I find out that the Kensington Astronomy at the Beach used to be a May event. Who knew? And back to you, Bob.
Wow, that's pretty cool. So, before I hit astrophotography, I'm going to do the solar stuff because I know as soon as I say astrophotography, it's going to be going crazy here. So let's share the screen because we're going to be showing what's going on the sun here. One of my favorite places to do that, let's see, screen one, is the NASA's Solar Dynamics Observatory site. And get this bar out of the way. There we go. I did mute myself. Okay. Can you guys see the sun here?
Yes.
Okay, so this is the photosphere of the sun. We have a gigantic sunspot group in the northern hemisphere there, and peppered with smaller ones all over the place. When I wrote my post for the VOF on Monday, we had like 8 named sunspots. So here's an animation in the last 24 hours showing a flavor of ultraviolet, and you can see Northern Hemisphere is sparking like crazy. So there's lots of flares there and lots of prominences. You see they're just spitting them out like crazy. There's a couple long-lived ones and a lot of really short-lived ones. Here is another flavor of ultraviolet showing the corona and coronal loops. And you can see those flares are poking at the sun's corona. So sun's very active right now. So let's stop sharing and all right, astrophotography. What do we got? Anybody got any astrophotos they've taken recently?
Well, I do have my really quickly, I may be able to pull this off and share my immaculate lunar eclipse shot that
Is that somewhere I can pull up so you're driving so you don't
yeah.
get into an accident? Where
Do
would
you
that
have
be?
a copy? Does anyone have a copy of it? Or because I posted it to Facebook, I think I posted it to Instagram, so it's out there. Um, it actually may not be too.
Let me see if I can pull you up.
Hitting up Facebook
Yeah.
right now.
Oh, here we go. It's not a very spectacular image by any means. It really isn't.
From Vegas?
Got
Let's
it
see.
here.
Here we go.
Oh, you got it? Okay.
Yep, that's it. The the story behind it is more spectacular than the resulting image. But the significance for me there was it was peeping through a pretty thick cloud cover.
Yep.
And it was in totality. So, as we know, the lunar eclipses all look a little different from year to year, or even 6 months to 6 months, however soon they come. Um, the characteristics of this lunar eclipse was a slightly brighter lower right limb than the darker area of the lunar eclipse was everywhere else. For the western coast, which most of the lunar eclipse photos came out of the west coast because there wasn't as much of an issue with clouds. Vegas had clouds, but they got thin enough, dissipated enough for me to get one or two shots off at it, and enough to just sort of be able to share with the world, literally. Oh, here's what I got. And then I went out and bowled. I did okay. I think I averaged 180 for all the games I bowled in the tournament. But I'll stop sharing now and let anyone else go. It was there was the quote, and we will go ahead and bring this up. Bob knows it very well. A particularly famous astrophysicist.
Oh, I was gonna bring that up.
Yeah, and that it's a subject of discussion on lunar eclipses being unspectacular, and I think a lot of us who do outreach would disagree. Some would agree. However, for me, it enabled me to do outreach to the bowling community because I showed them my picture, and there was more than one bowler who looked at it and said, "Oh wow, I didn't know that was happening," and we sat and talked about it. So even guys that started out saying, "Oh, I don't care about an eclipse," and I said, "Here, look," they stopped to look at my crude picture. So, and then I showed them the picture that I had taken of the past eclipse where I was able to get details, and generated some interest. So an unlikely outreach story from the catacombs of Vegas and bowling.
John,
I was very happy to have contributed. It made my trip, to be honest. So there, I've talked enough about lunar eclipses. If anyone else wants to share their story, if you got out of Michigan, you were able to share a story.
Johnny Horn posted a beautiful picture. You want me to raise it up? He's a
Sure, go ahead.
Let me see if I
Yeah.
let me get it. See if I can get it up here. There it is, right there. Can you see it? Okay.
Still
Should be
still
coming.
sharing. Still coming up.
Got it? Yeah.
I've got the dot. Ooh, that is pretty.
That's you know, he's
That was this year's. That was this year's or this past lunar
yeah. This
eclipse.
was at
Nice.
12:47 Central Time, I think, or something like that.
That's pretty crisp.
Okay. Yeah, the bright spot for that one is below, so it must have been as it progressed.
Yeah, he's quite a photographer. He's been I met him in at the 1991 big eclipse. Quite a photographer. I'll get.
Yeah, there were a lot of photographers shut out. If they didn't make it west,
Yep.
they were either shut out or they resorted to doing
Hey,
composites.
Ken, can you bring that back up again?
Sure.
Because I want to say, at the very top of the moon there, you'll see two stars, and I saw somebody post an animation on Twitter. Those two stars at the very top there got eclipsed by
Right.
the moon, occulted by the moon.
That's correct.
So those were I can't remember the
See
name
it?
of them.
Yeah.
Yeah, I was
yeah.
watching a live stream and I waited to see one of them actually get occulted by the moon, and it
That's
went out
cool.
just as it's been described before. It goes out instantly.
Mm-hmm. Snaps out. Point of light. That's
Yep.
why, right?
Yep.
So astrophotography and observing reports are kind of melding into each other. So do we have any other observing reports that don't relate to the moon from anybody? I have one actually. My granddaughter took me for a walk the other day. She's 2 years old, right? And she just and she walked down to the end of our subdivision and laid down on this grassy hill and looked up and said moon. And I looked up and there it was. And I'm like, oh my goodness. So I've had one experience with her with the moon, and I have no idea if her parents have had any. But if she remembered that, holy mackerel, that's amazing. But she saw it. I would have loved to have shown her this someday. So any other observing reports from anyone?
Well, the core of the Milky Way rises sooner and sooner, and now that we're moving to the dark of the moon, um, those of you that love looking at the Milky Way, about 11 p.m., the summer triangle rises in the northeast. Is it the northeast? Yeah, the northeast, almost due directly east. Cassiopeia rises in the northeast, and the galactic core with Sagittarius rises in the southeast. And Sagittarius is often the last of the constellations along the galactic plane to become visible. And most Milky Way shots feature in the northern hemisphere, feature the galaxy at that angle where it's up and you can see Sagittarius at one side and Sagittarius A star, which you cannot see, but there's a particular star that is pretty much a rough pointer to where Sagittarius A star is in the center of our galaxy. I hesitate to show an image just because it's me hitting buttons again while driving. But that is for a lot of people in the northern hemisphere, they call it Milky Way season. The truth is, the Milky Way rises high overhead. It's winter in the southern hemisphere, but they get a view of both sides of the galactic bulge and either side of the Milky Way, including the side that we can see. So I feel it's a misnomer to call it Milky Way season. For the northern hemisphere, just the point at which we can see the bright galactic core and the northern part of the bulge. And a lot of beautiful images are made with that as a background. So,
Yeah, you
that's
mentioned
it.
that the sun is rising earlier, and I always mention this in my posts because I have parrots, and my parrots go down with the dusk and up with the dawn, and which means they're up earlier and earlier every day. Yep.
There's the example of what I was talking about. Sagittarius is right here, and Scorpion is right over there, and that's what's in between them. For those who go up north and stargaze, you will see some of this. You may not see the color or the dust lanes, but you'll see a faint shape. So there you go.
That's gorgeous. I showed a picture of that to students in my astronomy club, my after school astronomy club, and only like one of the students had seen that at a dark sky site. None of the other students had seen that. I'm like, oh, we got to get you guys out to a dark sky site.
Yeah.
So, any other observing reports? All right. Well, I have something on here on the agenda that we haven't done in a while. Ask an astronomer. Do we have anybody that wants to ask an astronomer a question? Because we got plenty here, and I know there's some questions out there that people want to ask. I was actually playing a game the other day online, and I always mention to people that I'm a member of the Warren Astronomical Society, and occasionally I'll get somebody that goes, "What?" They had never heard of it. So he said he was going to join tonight. I don't know if he's here or not, but so I'm always trying to get new members in here.
Oh, Bob, I did want to mention one thing. Next Wednesday, I'm speaking before the Detroit Library, probably online. Jennifer Dye, who is in this meeting as well, arranges that, and I'm going to be giving the life and death of a star on
Nice.
next Wednesday. It
Yes.
starts around 6 o'clock.
Six.
Yeah.
Can you get with me at the break? I want to make sure that we promote that.
Okay,
Like
because
send out MailChimp
people
something
that
or
are
other.
relatively new to astronomy will get a kick out of that for sure. And
Um,
Jennifer's the best. Hi, Jennifer.
Hi. Ken, did I send you the link to the Eventbrite posting? I thought I had.
I think I have it, but I'm going to send you, based on that link, I'm going to send you the biographical stuff that you need. Okay.
Jennifer,
Oh,
can you
yes,
can
I
you
wasn't
link that in chat
I
sometime
can.
tonight? Awesome,
Yeah.
thank you.
So
Make it
Jennifer, you remind me that we did have another observation event that we did at Belle Isle that may not have been reported.
Yes. I was
And
hoping to
we
get there,
had
but I
a
didn't.
phenomenal turnout of 190 people. I think that was the
Wow.
estimate that came out to look at the moon and hang out with a few astronomers. I brought my scope. I had a little spotting scope zoomed in on the moon. There were a few other telescopes there, and a lot of people came out to Belle Isle behind the Nature Center. It was an old school star party. There were, I would say, about a third of the crowd used masking to try and to stay safe, and the rest were basically, we were saying we were outdoors. A good time was had by all, and it was. I think a lot of people were very gracious to just get out and do something. I had a lot of oohs and ahs because I had a close up of a part of the moon with the craters and some of there were some meh responses, but there were also some could hardly contain themselves responses.
We like those.
And, it was fun.
So are
So
there any plans to have another event like this out at Belle Isle?
I think so, and I'll turn.
Megan is hoping to, yes.
Say what date?
No, I don't have a date yet, but Megan is hoping to organize it again.
Yeah. Look, yep. So there you go, Bob.
All righty. Thank you. So again, back to
I have
Ask the
a-
Astronomer. Do we have it? I'm sorry, say again?
I have a question. I
We
would
haven't
say
answered. Let's see if they match.
it's astronomy related.
Yes.
2 or 3 months ago, I looked at some of the vendor websites that sell telescopes. It looked like they were sold out of a lot of stuff with no knowledge of when they would get more. I presume because they were coming from China, there's a lockdown on a lot of stuff there. Anybody have a sense whether that situation has changed?
Hmm. Well, I ordered a small telescope from Orion recently, and it came within a week. Now, are you talking like larger, more expensive scopes, or
Right,
was there?
like an 8-inch Schmidt-Cassegrain,
Hmm.
that kind of stuff.
I might be able to shed some light, working with the library telescope program. When Warren was trying to get their program started, they couldn't find an Orion Star Blast. And then I called Orion for the Warren Library, and they said that they discontinued it, and
Really?
there was no answer. So anyway, I got in touch with they have this website, librarytelescope.org, and they actually have a task force that meets once a month for the library telescope program. And I brought that to their attention, and next you know, they're on the horn with Orion, and they were getting different answers from everybody. So they thought it was a supply chain issue, and they were trying to refer the club to get the Skyscanner 100, a smaller telescope, but it doesn't have all the features as the Star Blast. So anyway, about a week later, the telescope miraculously appeared back on the website at an increase of $80 from what it was before.
Wow.
Okay,
Really? No
so
kidding.
there was big price increases.
Oh, my.
Cornerstones of Science used to they modified the telescopes. You could actually buy the scope right from them modified for a library. They do all the work for it. They were just getting out of the business. So what they were doing is the task force was getting in touch with uh, the owner of Explore Scientific, if I'm not mistaken, and to see if they could design a library telescope. So that way we can purchase. But their big thing from the owner there was how many are we going to be able to sell? You know, because they have to think of production. You
Sure.
know, to make sure it's worthy of that and
So,
everything.
so I know Scott Roberts. That's the president of Explore Scientific.
Right. So he was in touch with them. So that's what they were, getting the parts. And their big thing was how many would I have to make for a production run. But there is, I don't know if any of you also know that I guess Meade had a lawsuit filed against them and they lost. And if you go to the Meade website, their business address is the same as Orion's. Orion won the lawsuit and they own Meade property. So whether or not they're making meads, I don't know.
Wow.
It's tough to find a mead. I mean, it's just like a lot of the stuff is they post it on their websites, but there's just this, they're just not out there. So it's either says, I don't know what it means, out of stock, or discontinued is an easier thing for me to understand. But if it's out of stock, are you getting some back? So I'm either seeing out of stock or more on the way. So those are the two hints that I get right there. But I just wanted to just give you that on the library telescope, what we went through. So, but they are making them again, but it was a significant price increase.
Are you seeing a price increase on other scopes as well?
Um, so to give you, for instance, back in about 3 years ago, you could get a Celestron, like a Nexstar 5 for around maybe $700. It was going up to around $900. So it was like a $400 price increase, but now they got it on special. So I think they were trying to market out to see who will buy what's going on right there. But now you can get it down for about $700 again. Uh, and it was getting to the point where, like I say, me being an ATM or like making my telescope, it was almost to the point at one time that it was cheaper to buy a already made telescope than me buying the parts to make my own like Dob and everything. But it looks like it's flipped. Now it's easier to buy the parts and make a telescope cheaper than I can for buying it. Okay, and I can make it to, you know, my specifications and everything. So it's a crazy world out there. So, but a lot of it has to do with stuff coming from China, definitely.
Thank you, Mark. Yikes. All right. Well, it is 8 o'clock. Typically, we take a 15 to 20-minute bio break and coffee and munchie break. So everybody reconvene in 20 minutes. And if you want to stick around and chat, you can do that too. So we will reconvene at 8:20.
I'm going to have to leave, but good to see people
See you
again.
later.
And look forward to seeing you on Wednesday, Ken.
Yeah, I will be there. Can't wait.
Good. Thanks.
Jennifer posted a link to Ken's talk in the chat, sir. If you'd like to attend that, you can
I'll have
sign
that
up there.
biographical stuff for you tomorrow. Okay.
Thank you.
All right, well, I'm going to get some more coffee.
Well, yep, I'm still on the road and forgot that I hadn't
Jerry
grabbed any
Dunford, I have a
dinner.
question for you.
Go ahead. I'm going to be in mute and listening in.
On that talk.
Okay, yeah, I hear there's a question for me.
Yeah, that's right. This is Chris Rizzo.
Yes, Chris.
On that talk you gave about the occultation of Mars.
Yes.
You said you noticed an anomaly of a disruption of the light hitting the photosensor.
Yes, a few seconds before the occultation started, there was a fraction of a second.
My question is, did the airborne lab observatory see the same thing?
No.
Maybe it was atmospheric since you were on the ground.
We were on the ground, yes. We don't know what it was. It just suddenly appeared. It could have been something, it could have just been an airplane flying over. It's just cut off the light for a fraction of a second. Could have been a bird flying over.
Thanks.
We don't know what it was. No, as far as I know, no one else reported such an observation. So that's my only comment. It surprised us, and we don't have an explanation.
Thanks. I'm satisfied.
I have a question. Is anybody thinking of going to any astronomy camp this summer?
Are there any scheduled? I haven't seen anything.
I think they're going to have, what is it called? Starfest in Ontario in August this year. At least last I saw, they were pretty sure they were going to do it. They've done that every year for a long time until COVID hit.
Yep. How far up on Ontario? Where is it? Is it dark skies?
Fairly dark sky. It's about, if you're heading for Toronto, an hour before you get to Toronto, turn north and go 2 hours. It's up in that area.
Is that an event usually put on by the RASC?
No.
Okay, then yeah, I wouldn't be able to dig that info up.
I can probably find it here.
Dale, you've seen my my Leicas, haven't you?
Your what?
My Leica binoculars.
Yes.
Leica. That's the best binocular I've ever, I mean, clarity wise, the best I've ever used. It's just the optics on that thing are astounding.
I'm not
Yeah.
surprised, Ken. Leica has always been a
It
really fine optic.
just an amazing optic.
Yeah, some of their optics are in I think they're in the LG or the Google smartphones.
Okay.
So yeah, they're Leica competes with the Sonys, the Nikons, and the Canons
Well,
in the camera space.
my
But
father had
they,
a Leica years ago. I
yeah,
still have it somewhere. A camera. It
yeah,
still works. Yeah.
they are a pretty rare camera, but they are also a yeah, not as many people have them, but the ones
Yeah.
that do swear by them.
Yeah.
I have a great
Yeah.
pair of Nikons that'll be making my dark sky trips.
Good too.
And they're older Nikons 10x50s, and they do a great job of providing contrast, and they're a decent weight, so you know they hold steady. But I still plan on putting them on a tripod
Okay.
and having them track. Then you get a nice steady view. So that's my plan.
And then I have a 15 by whatever it is,
Probably 70.
70, I think 50 by 50. Yeah. Those are also pretty nifty, but they're like working with a tele. You got to put them on a tripod. They're just, you can't
Yeah,
hold them.
yep, I know the size. They're just out of reach of handheld for most.
Mm-hmm.
Ken, can you easily lay your hands on those Leica binoculars?
Yeah, I can get it right now. I'll get it, bring it right up. Interestingly enough, Dale, I found a set of Celestron 10 by 42 solar binoculars. They've got, the thing on that. That's kind of a cool one too. And this is the Leica.
Okay, how many, what, are they 10x or what?
The Leicas are, I'm pretty sure, are 8.
And what's that?
10 by 42. 10 by 42.
Okay, so they're 10x. What's the field of view on them?
42. 42 BA.
No.
What are you talking
10
about?
by 42. 42 tells you the diameter of the objective lens.
I'd have to look at that.
Just look at the binoculars. They'll
I
tell
am.
you so many feet at 1,000 yards or something like that.
I don't see anything except for a set of numbers on it, and it says Leica GmbH, and that's about it.
Doesn't say anything else.
All it says is 10 by Leica 10 by 42 BA, and I've had them for a long time, so I'm trying to see if there's anything else written on it. Hold on.
There's got to be a calculation for
Yeah, there's something there.
field of view. If exit pupil's 10 millimeters in diameter and objective is 42,
right.
there's
I see nothing else on it, honestly.
Okay.
There's nothing.
I mean, I remember you let me look through those several years ago, and they were just super sharp imaging.
Super sharp. Yeah.
But they probably don't have a very large field of view.
I don't know. I wish I could tell you that. I don't really know.
Okay, just curious.
It has an independent focusing.
Yeah.
Each one, for each light, you pull this thing out, and then you can focus each individual lens, however you want to do it. And then there's this, trying to see, maybe it has it in there. Plus, minus. It's just not on there.
Okay.
Just isn't on there.
Probably 5 or 6 degrees.
Maybe, I don't know. Interesting serial number there. It's got all kinds of stuff on it, but there's nothing there that. Let me see if it says it in here. Could. Attaches to its own. It's got all the bells and whistles. It just doesn't have anything on that. I could probably look that up though. I'm going to take a shot at that.
Are you seeing the image I'm sharing?
Yeah.
It's the one Steve Vagas took.
Oh, cool. I love it. Let me, I'm going to do a little.
Where did he take that?
Let me see where is
it was in Arizona.
Arizona, yeah.
I got one from Fred Espenak today too. And he said that he had high cirrus though, so it wasn't quite as good as he wanted it to be.
Is that a star on the limb of the moon that I see?
It is
Yep.
Exactly right. Yes, that's correct. That's the one that it occulted. That's the one that it occulted. It was about 9:30, 10 o'clock.
Yeah, that's a HIP
That's the one.
76106.
That's the one.
If you want to look it up. In fact, if you Google that, you'll find another fellow down in Mexico who took a picture of it exiting from behind the moon.
So, Dale, I think the field of view something like 330 feet at 1,000 yards. Might be. This is what I'm seeing for 10 by 42 binoculars. Field of view greater than 330 feet at 1,000 yards.
Yeah, that's 6.3 degrees.
Is that what it is?
Okay. Yep. So, yeah,
Yep.
I was wondering
There it
if
is.
the estimate was going to be 6 degrees. So you're
That's what it is.
6.3
It is.
degrees. So around a 6-degree field of view.
Yep, that's it. I just found it myself.
If the moon is like 1 degree, field of view is 1 degree, right?
Right.
No,
Right.
half a degree.
It's
Half a
half a degree.
Yeah,
Okay.
it's 30 minutes of arc.
Okay. So I would have to, yeah, I'd have to do a rough estimate based on how big I know the moon is in my 10 by 40s. Now I don't have to. I just looked it up. I let the almighty internet tell me what it is. And sometimes it tells the truth. You just have to go to the right sites. I
You know
did
what
not
they're
go to
selling?
Facebook to find out.
You know what they're selling that thing for now? Selling it
$3,000
for
bucks.
$2,000 for the damn thing.
Okay. Oh, it's on sale. I think I saw one for 3,000.
There's one for 2,200, and good God, really? I don't believe I spent anywhere near that.
No, you probably didn't.
No.
Well, I'm
4-minute warning.
about to sell some equipment because there's a lens that I got was worth around 1,900, and there's some equipment that I am going to sell to offset that cost. But
2,800.
lens, that lens essentially replaces 2, if not 3, of the lenses that I own. So it's very good for general photography, which I do a lot. If I'm being paid to do photography, I tend to be doing a lot of that where they want me to capture certain things. So now I don't have to bring a whole bunch of lenses. I can bring a camera, a lens, and an imagination and go for broke.
Speaking of going broke, I was looking at Lunt solar telescopes the other day, and
Yeah.
they have a 153 millimeter solar scope for $9,000, and my wife looked at me going, she's actually willing to let me go about 2,000 on one. I'm looking at getting a solar scope. My Ph.D. 40 just isn't doing it anymore. I took it to school, and the darn thing's just got such a sweet spot, and the students just can't find it. And I've already had the coating on the thing replaced once, and I had it in full sunlight, and the image was just dim. So I'm just like, time for a new solar scope. So now I gotta figure. Now I want something that's quick and easy to set up, no freaking batteries, you know. So something I can take to a school, set up, and have the kids look at like right now, and something that's tracking is not necessary, but I gotta have those things that do that because camera tripods are not the right thing for a solar scope.
Agreed.
So,
Hey, Bob,
and yes,
I recently repaired 2 PSTs. One of them, when I was looking into it, I just saw like an orange glob. And I went through Cloudy Nights and asked about, seeing if anybody had issues with it. And they referred me to a company called Meyer Photonics. They make tons of filters, all different applications, scientific applications. And they happen to sell, this is called a 656, with the angstrom bandpass filter, specifically for the Coronado. And it's just where you put in your eyepiece,
mm-hmm,
you screw off that barrel, and the filter sits right in the bottom of that.
mm-hmm.
And Mead used to charge around $250 to replace this. You can get this for $75.
I
I
might want to be
I put
talking to you after this
I
meeting.
put I put this in. I put them in both of my. The other one was I wasn't sure on it, and I put a brand new one in that just to make sure, and they both compared favorably. One of the issues was they talked with the PSTs. They had an issue was called rusting, and
Mm-hmm.
on the edges of the filter, they have like an epoxy seal, but they did that later. But all the earlier models, and what happened, the filter, like one side will look red, the other side looks purple, but the whole thing will look cream color.
That's what happened to mine.
Okay, and
I
that's
had to
and
send
that's
it
what
in
it.
from to replace it, but I don't know if it's doing it again, but
Yeah,
it's just the image quality was like
yeah.
crap. So
So anyway, I replaced them like $75 a piece, and they turned out really good and everything. So, um, But anyway, it was a nice learning experience. When I talked to the gentleman there he says, yeah, we sell a ton of them. So that's one of the big things that happens to the PSTs.
I will be getting with you on later on this, but it is time to resume our meeting, everyone. I'm going to be introducing our speaker tonight as Dr. Dale Partin. He is, let me get this over here.
By the way, that's 6.3 degrees.
All right, Dr. Dale
That's
Partin,
right.
our speaker tonight. He's an amateur astronomer and teaches astronomy at Macomb Community College. He has a bachelor's and a master's degree in physics and a Ph.D. in electrical engineering. Until his partial retirement, he worked in advanced research in the auto industry. He has over 80 scientific publications and 38 patents, and is a fellow in the American Physical Society and a member of the Sigma. How do you pronounce Sigma Xi? I don't know how to
Sigma
pronounce.
Psi.
Thank you. And the American Scientific Affiliation. He has joined the Warren Astronomical Society in 1998, gave his first presentation that year on his measurements of the orbits of the Galilean moons. He has served as a WAS officer many times since then. Tonight's lecture he gave an earlier version of in February of 2014. He's going to be, I'm not going to cover it too much, he's going to be discussing ultra wide angle binoculars. And take it away, Dale.
Okay, thank you, Bob. Before I put up my PowerPoint, Ken, do you want to show that binocular I sold you all those years ago? Any comments on them?
I've got a set just like it, and so does Diane.
Ken, you're muted.
There you go. 2.3, 2.3 by 40 is what it is. And they are terrific. I mentioned to Dale briefly that what I would do is I take this pair of binoculars when I be teaching youngsters, because they could handle this a lot better than a larger one, so that they get an idea what to do, and then they'd look at the moon or whatever it is, and then I'd give them the other ones, and they have an idea of what to do. And it was a great teaching tool, but it certainly it's a wonderful unit, and I'm forever thankful to Dale for selling that to me. It really is great.
Okay, I'm going to be talking, among others, about that very pair, which I sold them to Ken back in the day. And I'm also going to be talking a lot. The first part of my talk, or early part of my talk, will be concentrated on that pair Ken just showed you, and on these, which are 4X binoculars. They are 4 by 22 binoculars. So most of the binoculars I'm going to concentrate on are 2X binoculars, like the ones Ken showed you. These are 4X. These are the other two pair of 2X binoculars I'll be talking about. When you talk about especially 2X binoculars, you cannot wear glasses with these binoculars if you want to see a large field of view. Another point I will make is the closer you get them to your eyes, the wider the field of view you will see. And what I do, I'm deliberately turning sideways. I hope you can see what I'm doing. I put them up until they just touch my face, just below my eyebrows. That's how close I get with them. I could get closer and see more, but right there is what I do with these kind of binoculars. And incidentally, you put them there and then you move them up and down until you get a clear view. So well, let me get into my PowerPoint. Let me find how to share. Oh, here it is. How's that look?
Perfect.
Okay. So the presentation tonight is ultra wide angle binoculars. I am chewing gum, which I need to do to keep lubricated, so I apologize for that. By ultra wide angle, I basically mean a field of view of at least 10 degrees, preferably at least 15 degrees. An alternative title for this talk would be, why would anyone want low magnification binoculars, right? Don't you want to magnify things? Uh-oh. I guess I can do it that way. My down arrow key is not advancing slides, but I can do it with my mouse. So I'll briefly talk about different binocular designs, then characteristic of night vision, then a little bit about 7X binoculars, because some of them have a field of view that's kind of getting into the wide angle range I'm after. But most I'll be talking about 3X, 4X, and 2X binoculars. And an important thing I looked into was not what field of view do they claim they have, but I measured their field of view. And what is their optical gain? Binoculars don't just magnify what you see, you can see dimmer things. So you get some optical gain from them. So I measured the optical gain. So one of the things, I mean, I guess I'm not a great astronomer, because when I use typical binoculars and I look around and say the Milky Way and I find something interesting that I want to look at with my regular telescope, I take the binoculars down from my face, and then where was I? Where was I looking? I didn't have a wide enough field of view to be able to tell where I was looking. So that's one thing that motivated me to get into these wide angle binoculars. Another is with a telescope or conventional binoculars, you're focusing in on kind of one real little area of the sky. I find it to be a very different experience of the sky when you look through wide angle binoculars, especially when you look at something big like the Milky Way. Just sitting in a lounge chair, scanning the Milky Way. It's enjoyable to look at it naked eye if you're in a dark place. With ultra wide angle binoculars, you feel like you have supervision, okay, compared to naked eye viewing. Obviously, if we ever get a comet again with a really long tail, these would be really nice to have. You can see a whole constellation or most of a constellation with them, and it can help you learn to learn the sky. But if what you're going to do is compare them to your usual 10X binoculars, and you're going to say, okay, I want to compare looking at something small in the sky with 10X binoculars versus 2X binoculars, the 10X binoculars are going to win, because you're going to typically, they have big objectives, and they pull in a lot of light and give you more magnification. So you have to appreciate what they're good for. They're not going to be anybody's only pair of binoculars. They're more like your second pair of binoculars. So in a typical telescope, which a binocular is sort of like two telescopes, you have two convex lenses, an objective lens, and a eyepiece lens or an ocular. And here's the focal length of the objective. Here's the focal length of the eyepiece. You take the ratio of this focal length to that focal length, that's the magnification. You get an exit pupil, the size of the beam coming out, which is the size of the beam going in, divided by the magnification. You get an inverted image, up arrow versus down arrow. And if all goes well, the exit pupil is smaller than the entrance pupil of your eye, so you're not throwing away light hitting your face above and below your pupil. The field of view of the telescope, FOV, equals the apparent field of view of your eyepiece, which is usually a function of how much money you spent on it. The more money, the larger the apparent field of view of the eyepiece, divided by the magnification. I have to say that, so here's the formula. And the important thing to note is the smaller the magnification M gets, the bigger the field of view gets. Okay, that's sort of inherent in optics. So if you want a real wide, big field of view, you've got to use a small magnification. These formulas don't necessarily work super well when you get to super wide fields of view. There's some approximations that go into these formulas, but they're roughly correct, unless the manufacturer puts some stops in the optics that limits what you can see. So conventional binoculars have a prism inside to flip around the image so you get an erect image. There's various designs that will do that use all convex lenses. There's a different kind of optical design that uses a convex lens for the objective, but a concave lens for the eyepiece. This is the so-called Galilean design. Galileo used this kind of design in his telescopes, and you do not need any prism or any kind of optics in between to get an erect image. So these are commonly used for the lowest magnification binoculars like opera glasses, and the exit pupil is typically way bigger than the entrance pupil of the eye. A lot of specifications matter for binoculars. Magnification and aperture are obviously two of them, like 10 by 50. 10 is the magnification. 50 is the diameter of the objective lens in millimeters. Field of view, which I'll be very concerned with here. For example, a lot of times they'll spec them. Sometimes they'll tell you how many degrees the field of view is on the binocular. Other times they'll give us how many feet it is at 1,000 yards or meters at 1,000 meters. If it's this kind of spec, to calculate the angle in degrees of the field of view, you take 524 divided by 3,000 feet. That'll give you the angle in radians. And then you multiply that by 180 degrees over pi, or 57.3 degrees. That'll give you the angle. As far as exit pupil, all 10 by 50 binoculars have the same exit pupil, which is you divide 50 by 10, so 5 millimeters. Other things that matter are weight, ease of use, focusing, eye relief, clarity of view, and of course, cost. Eye relief is a big deal with these ultra wide angle binoculars. By the time you're at 2x, forget using glasses. So a kind of intermediate magnification heading toward wide angle views is 7X binoculars. There are kind of 3 standards that I've seen. By the time you're up to 7x50 binoculars, the exit pupil is 7 millimeters. Many people have smaller pupils when their eyes are dark adapted than that, so you're throwing away light. So a better choice might be 7x35 or 7x32 if you can find them, so that the exit pupil of the binocular is smaller or is comparable to your pupil size. I did, when I did this study back in 2014 or 2013, on eBay, I bought a cheap pair of these. More recently, I bought a used pair 7x50s locally at a sale, an estate sale. The cheap ones claimed 11-degree field of view. I measured 10 degrees and a very distorted view near the edges of the field of view. Here's the Big Dipper. So you'll see this diagram a number of times in this presentation. It's an easy way to measure field of view. The 7x50 binoculars had almost as good a field of view as the 7x35. Actually, it's a closer comparison than you see here. I just couldn't get the software to let me make the size of circle I wanted. They're almost indistinguishable. I wish I could have got a pair of these. They haven't been made for many years. They claimed 14-degree field of view. I could never get even a used pair. One Cloudy Nights reviewer said he measured 13 degrees field of view, not 14, 6.5 magnification, not 7, and other problems. So this is one of the binoculars that I studied a lot. I had to buy it at the time direct from Japan. Back then, the yen-dollar ratio is about 100, so they cost me $124. In 2018, I recently found somebody was selling them for about 30 euros, which is probably $35 or $40. I was a little disappointed when I saw that. But you can't buy them at any price now, as far as I can find. Maybe you could pick up a used pair sometime. But I have a pair of these, and even though they're not fully multi-coated, I kind of like them quite a bit. I'll be talking about them. These are their specifications. Like I said, I had to buy them from Japan. I ran the specs through Google Translator. Ultra low magnification binoculars, indicating special called 17-degree field of view. Grade 2 or more than the naked eye, they mean you can see at least 2 magnitudes deeper into the sky. Apparent field of view of the eyepieces is 68 degrees. So not too bad there. They could have been 50 degrees. Overwhelming sense of relief that it was not possible to taste with traditional binoculars. Easy to become addicted to them. So here's the field of view I get with them. Remember, the 7X binoculars are more like this. They claimed 17 degrees field of view. I measured 17 degrees. The view is somewhat distorted near the edges of the field of view. The optics are magnesium fluoride coated, not fully multi-coated, but I like them quite a lot. I never sold these after I studied them. I did sell the 2X ones to Ken Burton, as he mentioned. These are kind of different. Wearable 3X binoculars. They only weigh 2.5 ounces. I got them off eBay for $110, and they use the Galilean design. No prisms. That helped keep them small and light. I was a little disappointed in the field of view. It was only 11 degrees, but a very clear view, pretty much right to the edge of the field of view. You can adjust both the focus and the interpupil distance. Kind of a nice experience to just look up in the sky without having to hold them. Somebody at the Ford Club talked me into selling these to her. I regret it, but I did get talked into that after I gave a talk on them. The other binoculars that I studied a lot were these. I sold them to Ken Burton. He showed them to you a few minutes ago. Again, I had to buy them direct from Japan. 2.3x by 40 millimeter aperture. Notice the exit pupil is 17 millimeters. If you take 40 and divide it by 2.3, they do have a field stop here at 8 millimeters to limit that. They claim 28 degrees field of view. I measured 20 degrees field of view with my eyes close to the lenses. The way I showed you with them just touching just below my eyebrows. Mostly a pretty clear field of view, fully multi-coated lenses, individually focused eyepieces, no glasses, and now the field of view is out to here, to the star in the middle of the handle of the Big Dipper. So then I wanted to closely compare these two binoculars in terms of how dim of an object I could see. What's the faintest star I can see? So I used the Little Dipper for that study. Both comparing these binoculars to each other and to a naked eye view of the sky. So that addressed the question, how much dimmer of a star can I see with either of these binoculars than I can see just with glasses on? So here's the cup of the Little Dipper. I printed out part of a star chart. These are the magnitudes, like 8.4, 6.9. You can see a couple of things. One, I needed a chain of magnitudes. So if I could see a 6.9 magnitude star, then I wanted to find a 7 or 7.1 magnitude star. So you can walk in steps, preferably 0.1 magnitude at a time, from star to star. The dimmest star I could see, and I think this is up north, I had 2 observing sites. With the 2X binoculars was a 7.5 magnitude star. With the 4X binoculars, I could go another magnitude deeper. So here are those 2 stars. It's not easy to make those measurements. It is very difficult to make those measurements. It is really hard. It was really fun, but difficult. It's not like estimating stellar magnitudes where you can see the star and you can see another star with a little higher and a little lower magnitude. Here, you know, you're not doing that. You're pushing your eyesight to the limit, the faintest possible star you can see. You need guide stars, not too bright and not too close, because most of the time you can't see the star you're looking for. You just keep looking and looking and looking. So you need a star nearby to where you know you're looking in the right area. Use averted vision all the time with this stuff. Observe trying to see a star many, many times. Most of the time you can't see it. In the end, I was always at least 80% sure that I'd seen it when I got to the limit of what I could see. I'd have a pair of larger aperture binoculars to look in the same area to see exactly where the star was and kind of memorize where to look. Don't rely exclusively on star charts. Real important, your eyes must be super dark adapted. Not mostly dark adapted, completely dark adapted. Use a very dim flashlight to see the star chart. I have one of those red flashlights where they have a 9-volt battery and a knob where you can adjust their brightness. I couldn't get them dim enough. I had to use an old 9-volt battery that was weak to get the thing dimmer. And then turn the light off and don't use it at all for the next 15 minutes while you're trying to zoom in on a star. Only do measurements on stars in the same region of the sky. Excuse me. Stay away from the Milky Way. It acts like light pollution, no moonlight. And I did measurements both in my backyard and up 20 minutes north of Capac. There's a darker area. Repeat on multiple nights. You do get better at it with time and experience. A more refined study might take account not just of stellar magnitudes, but also star colors. Here I just avoided red stars. This is a document I found off the web from the Army regarding pilots who fly for the Army. Talk about the fact that when you're fully dark adapted, the rod cells in your eye may be up to 10,000 times more sensitive than at the start of when you had them exposed to bright light. 10,000 times is actually 10 magnitudes. Through a dilated pupil, that increases your sensitivity even more because your pupil opens up. So you can get close to 100,000 times higher sensitivity with the rods in your eyes once you get dark adapted. You have rods and cones in your eye. The cones are what you see color with. The rods can see shades of gray and much, much more sensitively. So if you look at this graph, it says your sensitivity gets greater out to about half an hour. The reality is it keeps continuing to become more sensitive, a few more tenths of a magnitude. And that matters for these measurements, so you have to wait longer. They're saying if you're exposed to intense sunlight for a few hours, that can affect your dark adaptation for several hours. And these effects, if you get too much light, can affect your night vision for several days. When I drive up north of Capac, I would try to avoid even looking straight ahead on the road if I had oncoming headlights. So in your eye, if this is the center of your retina, that's where your color sensitive cones are. But those things are almost blind to low light levels. So that's why you use averted vision. Your rod density is much higher off center. So I was operating in this area all the time. But with these real wide angle binoculars, you've got light hitting. I mean, with say 10x binoculars with a 6-degree field of view, if you're looking straight ahead, not using averted vision, you're maybe using this much of your retina. If you're using these ultra wide angle binoculars, you're using the whole thing. Light is hitting you over a wide range of angles. Also, your rods are less sensitive to red than your cones are, which is good. I measured my pupil diameter. I had to do it in the dark and then bam, hit my wide open eye with a flash of light. It's almost painful. I measured 6.8 millimeters. So for somebody who's older like me, that's quite good. A lot of people as they age, their maximum pupil diameter starts to shrink. I found a paper that talked about some of this stuff. It talked about how fast your eyes respond to light getting dimmer or brighter, where your pupil diameter responds in a matter of seconds. My experience measuring my pupil diameter did not agree with this. After getting a whopping big flash of light from the camera, it could take a few minutes for my pupil to fully dark adapt again. So here is my data. My first 2 observing trips, number 1 and number 2, I don't record here. I was just developing technique. Then trip 3 and 4 were to my backyard. On my best final measurements at home, the naked eye limiting magnitude I could see in my yard was 5.3. With the 2x binoculars, the limiting magnitude was 6.9. So if you subtract, I gained 1.6 magnitudes with these binoculars. The 4x binoculars could see dimmer stuff, so I gained 2.5 magnitudes. I then went up north twice. On the last trip, I saw 0.7 magnitudes dimmer stars naked eye, and these magnitudes of stars. So the important thing to me is I got the same increase in how dim of a star I could see with both binoculars. For a not fairly light polluted sky, I got these gains in magnitudes. For a darker sky, I got these gains in magnitudes, same gain. So with the other binoculars, I don't have a diagram like this one to show you what's going on in the optics. Looks like they had an achromat lens here, I guess is what it is. So if your pupil diameter is D, then it turns out that only light, since the magnification is 2.3, only if you're looking straight ahead, only light that's 2.3 times d in diameter can make it into your pupil. If your pupil is bigger, 2.3 times your pupil diameter gets bigger. But it's still a small piece of glass that gets into your eye from a specific object. So a question I started thinking about was, am I only using the central part of this whopping 40 millimeter diameter lens? Why is this glass so big? With these binoculars, they do have a prism, and with D equal to 6.8 millimeters for my eye, the theoretical gain I get is 22 millimeters divided by 6.8 millimeters squared to take into account the area of this cone of light coming into my eye. Fortunately, my eye has a larger pupil diameter than the exit pupil of the binocular, so all the light can get into my eye. If someone else has a 5.5 millimeter pupil diameter, then that'll just exactly match up with the 5.5 millimeter exit pupil. You can actually get a higher gain. But if your pupil diameter gets smaller than 5.5 millimeters, you start to lose gain because some of the light can't get into your eye. So the theoretical gain for the 2.3x binoculars was 1.8. I measured 1.6. Theoretical gain for my eyes with these 4x binoculars is about the same as what I measured. I also noticed that I could, even though looking at an object straight ahead, I could only use this much of the glass of the objective to see that object. I could see a blurry image of my fingertips if I extended them out in front of the optics. So why was that if I'm only using this much of the glass? The answer is, of course, you're using all of the glass. If you look straight ahead, this much of the glass is used to form an image in this part of your retina. But while you're looking in that direction, other light is coming in through other parts of the glass and getting focused on a different part of your retina. That's how you see an image. So this is a summary of the field of view I measured for 4 different binoculars. The red is the 4x binoculars, spec'd at 17 degrees. I measured 17 degrees. Then these are the binoculars, the 2.3x ones that I sold to Ken Burton that I showed you. They spec 28 degrees. I had measured 20 degrees. I had found that to be, frankly, disappointing and confusing. Why were they saying 28 degrees? At the time I did this study, I didn't have that figured out. Now I think I have it figured out. I'll go into that in a minute. But when it came down to which one of these binoculars am I going to use more, I chose these and sold these with some pressure from my wife. So more recently, that's as much as I studied back in 2013. More recently, I've taken a look through these 2 pair. I bought a pair of these 2x by 54 millimeter Orion binoculars. They spec 36-degree field of view. I measured only 27 degrees. Still a big piece of the sky, but why not 36 degrees? And I found out Bob Berta has a pair of these Vixen binoculars specking 25 degrees. So he loaned them to me, and I measured 22 degrees field of view. So the only binoculars that gave what they said they would give were these 4X binoculars shown here. So I've got this pair, and I also own this pair. It occurred to me what was likely going on, and I was correct. What I did is, I mean, normally when I look through these binoculars, I hold them still against my face and I look around through them, but I'm not moving them around on my face, right? Normally you don't do that when you're holding binoculars. So I put them on the stand and then look through them, where instead of centering my eyes here and here, I moved my eyes off center one way and saw what's the most extreme thing I can see. And then I moved my eyes over to this side. What's the most extreme thing I can see? Then I can rotate this. It's calibrated in degrees. I could figure out the full angular field of view when I move my eyes back and forth here, which is what you often do with a telescope when you have these 80-degree or 100-degree apparent field of view eyepieces, right? You can't usually see that full field of view unless you move your eye back and forth in front of the eyepiece. You just don't normally do that with binoculars. So for the Orion binoculars, the measured field of view increases from 27 degrees measured with the Big Dipper to 36 degrees measured this way, meeting the spec. However, the view is very distorted at these large angles. I would say useless. So 27 degrees is the effective field of view. Unless you're willing to put your eye even closer to that glass than I do. I'll come back to that in a minute. So to get a clear view with these Orion binoculars, you must take off your glasses. And as I described, having the top of the eyepiece covered, just barely touching me, and adjust the vertical tilt angle to optimize the view. I don't think you would mind if I tell you this. The friend I refer to here, do I want to give his name? I guess I will, is Jonathan Cade. He also has a pair of these same binoculars. I'm sure most of you who know him realize he normally wears glasses. He cannot get those things to focus on infinity with them. There's not quite enough travel in the adjustment, in the focus adjustment for him. I can do it, but maybe my eyes they're closer to normal vision than his. Another problem with these Orion binoculars is this is a picture of the rubber cover that fits over the objective lens. The problem is these things are so big in diameter, this rubber is so flexible that if you're not careful, if you put the cover on the lens and try to pick it up that way, the lens cover will touch the objective lens in the middle, and it'll leave a little smudge. So I found a round piece of plastic that was just the right diameter to fit down in there, so that when you put the lens cover on the binocular, it doesn't quite slide all the way down. That seems to fix the problem, although I'm still careful with them. And by the way, I found on cloudy nights where somebody else had a pair of these and they noticed exactly the same problem. So as far as the 2.1 super wide constellation binoculars by Vixen, Bob Berta loaned me a pair of his to evaluate. I read a review. Here's the link. That the field of view is, for these binoculars, is actually 28 degrees, whereas the spec was 25 degrees. I measured 22 degrees. The closer you get to your eyes to the eyepieces, the wider the field of view. They say in their review they had their eyes so close that their eyelashes would leave marks on the eyepieces. I think that's crossing the line. I didn't do that. That review also compares them to this binocular that I previously talked about. So these are at least both binoculars that you can buy today, whereas the Kasai 2X binoculars, I can't find any place to buy them. The Vixen ones are more expensive, weigh a little more. The Orion's spec and deliver a larger field of view. Both of them get a little bit blurry near the edge of the field of view. Bob Berta claims that if you slightly defocus these in the center of the field of view, you can make them better focused over a larger part of the field of view. I tried that, and that seems to be correct. Excuse me. The thing I want to say is, I think these give a overall better optical quality in terms of clarity, overall clarity over most of the field of view than these do. So I called this an A and this a B. Maybe I could call this a B and this a C. Whatever, I'm saying these, I just never have felt that the optical quality was as good as I wished it was. Hate to say it, but that's the case. Okay, so I've looked around for, are there any other 4X binoculars similar to the ones I have on the market? These ones I got from Kasai, I can't find them anywhere for sale. I found different 4X binoculars. This is an example. They claim 18-degree field of view. I don't know if they deliver that or not, but you can't focus them. There's no knob to turn. They talk about like that's an advantage. You don't have to worry about focusing. Interesting kind of advertising. I also looked around for whether some of the high-end binocular companies that make binoculars sell binoculars with less than 7x magnification. As far as I can find, none of these do. Zeiss 100 years ago was making 4X binoculars, okay, with a field of view of 10 degrees. That's all I could find. So I did find a pair of 5 by 25 binoculars. Again, mine are 4 by 22. Sometimes you'll find them called Vision King. Other times they give no brand name. They'll just say they're 5 by 25 binoculars. And if you look at them, they are identical. Where did I find this? I forget what website I got these off of. $66 for a pair. So, you know, the optics may vary from one binocular to the next. Oh, from eBay, I found them, and they had a bunch of them there. This was a week ago. They claimed 15.8 degrees field of view. Someone reviewed them and said they only got about a degree less. Still pretty good. And you're getting 5x, not 4x. 15 millimeter eye relief, pretty good. Fully multi-coated green, whatever that means other than they look green. They have a central focus knob and a right eye diopter adjustment. Here's a review on them where different people keep talking about them back and forth. I don't have a pair of these. I considered buying a pair, but I'm already kind of on the edge with how much stuff I buy relative to my spouse. So I didn't buy a pair. So low power binoculars in the 4x to 2x range give ultra wide fields of view and give a deeper view of the sky. You can see dimmer things than you can naked eye. So compared to naked eye viewing, I'm not talking about comparing to some super duper 10x binoculars with a smaller field of view. They give what you could call supervision. And I guess that's it. Let me stop sharing. And I'm open for questions. Yeah, Riyadh.
Yeah, I have a question. Thank you, Dale, for that excellent presentation. Extremely detailed. It's fantastic. For the club, I just purchased the Orion binoculars, the one you just mentioned. Now, on their website, they have a YouTube video where they talk about the exit pupil for these binoculars, and they do say something that on the order of that, the exit pupil is not calculated the same way on these type of designs of binoculars. So I'm not sure if you've had a chance to look to see whether these Galilean type designs would have different exit pupil or not, but that's what they say on their, in their own YouTube website.
The exit pupil is huge.
Yeah.
You just, I don't want to say it. You just look out a window with them. I mean,
Yeah.
And you just see this light coming through in a big beam.
Yeah, but I also have a pair of 20 by 80 binoculars. They're Celestron binoculars. I bought them in the 80s. I'm not sure if they make them anymore or not. Well, they're 20 by 80s, but they have extremely large eyepieces in the back. And when you look through them, I mean, it's, I don't think you have a huge exit pupil just because the eyepiece is large and you could see through it like that.
Yes,
like you
I
mentioned.
know.
So I'm not sure.
Did you see a claim for what the exit pupil was?
On what? On the 20 by 80s?
No, on these Orions.
No, they don't mention it. They just say it's not calculated the same way and it doesn't work the same way. So that's all they say. So I'm not sure.
Okay. Well, some of them put in a stop that limits the exit pupil. I think the Kasai one's limited to 8 millimeters. They just put in an aperture.
Yeah, but that doesn't really change anything because, okay, that light, let's say the exit pupil is larger than your eye still. Well, that light that was getting wasted around your eye is now getting wasted inside that aperture.
Yeah, but you can move your eye back and forth like this if you want to push the specs.
Well, that's just for the angle, correct? But the exit
Well,
pupil, we're
that's
talking
field of
about,
view.
yeah, the field of view. But aren't we also talking about the magnitude is affected by that?
Yes.
Yeah.
Look, I didn't see that on Orion's website. I bought those Orion binoculars at least a year ago, maybe 2. I don't know if they had that on their website at the time, so I didn't see that.
Well, I bought them because I thought, first of all, they're similar to other binoculars. They were easier to get a hold of. And the large eyepieces in the back, I think, would make it easier for most people in the club to be able to look through them easily.
Yeah, I mean, I'm not sorry I bought them. I'm just saying there's something about how easy it is to get the vixens to have a reasonably well-focused view across the field of view.
Okay.
It's just a little easier to get it for me.
Okay. Yeah. Well, thank you.
Sure.
I got a question, Dale. Is there some mechanism on those small binoculars that will allow you to compensate for different strengths of each of your eyeballs?
For different what?
Different strengths of each of your eyeballs.
Yes. I mean,
I didn't see it on there. I didn't see it on the binocular.
if you rotate the eyepiece, you can use that to focus each eye separately.
Okay.
All of these binoculars, all of the 2X binoculars I've looked at can do that. However, as I said, Jonathan Cade says he can't get them to focus on infinity for at least one of his eyes.
Does he have, and do you have astigmatism, Dale?
I do not.
Okay, that may be the reason. I have astigmatism. I have difficulty focusing just about any binoculars with my glasses on, or with my glasses off, rather. Sorry.
Works against
Well, talk to Jonathan. My interpretation of his statement is he could almost get the focus as he turned, and then he ran out of turn.
You were talking about distortion at the edges. Is that inherent to most binoculars that you find, or is it just for the? You were saying there was some of them get distorted at the edges, and do you find that with all of these smaller binoculars, or I'm trying to pick up on that because I haven't seen too much distortion in any of them that I've used. Maybe I'm just not noticing it.
A lot of people see it. It depends on how you use them, whether you see it very much or not. If you put them up your eyes and you're kind of looking straight ahead, but letting your peripheral vision see out near the edges of the field of view, your peripheral vision is not that good anyhow.
That I
So
understand.
you don't notice the distortion that much. But if you look to the side, then you can see it more.
Ah, okay. That explains it. Thanks again.
Yeah. I mean, it was quite a revelation to me when I realized why these 2X binoculars never, in my experience, meet their spec for field of view. When I realized they were doing this, moving them back and forth, you know, which to me is, there's some degree of truth in their spec, but not very much, especially because when you do that, the view you see is worthless in terms of quality. It's really bad. But they do meet their specs when you do that.
That's
Tell you the
I-
truth, it only dawned on me what they were doing about a month ago. And I tried it the way because I remembered what you do with wide angle eyepieces on a telescope. You have to move your head back and forth. But there you're usually paying hundreds of dollars just for that eyepiece, right?
right.
So they put that money to work with lots of pieces of glass to give you a pretty clear view when you go back and forth.
I see.
With these binoculars, you're not paying very much, and you got to have two of them. So the money just isn't there. That's why I looked at Zeiss and the other high-priced manufacturers, and none of them seem to be interested. I even contacted the president of Oberwerk and said, you know, they make pretty good binoculars. And I said, you know, there must be quite a bit of market for this if somebody would just put the money in to make a really good one. Didn't go anywhere.
Didn't go anywhere.
I mean, they're probably more interested in higher power binoculars where lots of more people are interested in them.
Money.
Well, I can't blame them. They're in business.
Of course. Agreed.
They have to see the market there. If they do something new, you know, if they put more money into making a higher quality, low power binocular, just advertising it so people would know costs many thousands of dollars.
Sure, that's absolutely.
I once had somebody, I was suggesting this simple thing to change, and he said just advertising is $10,000. You know, so
big price. Because there's a lot of competition too. So there you go. That's why.
well, here yes, I mean, a lot of people are going to say, well, okay, your $500 pair or $1,000 pair of 2X binoculars is better, but I guess I'll settle for the Vixen or the Orions, you know, because my wife can't understand why I would want to pay that much for binoculars that have such a low magnification, you know. I mean,
Good point.
Dale, one of the comments I want to make is the first time I looked through your binoculars a few years ago, the Kasai binoculars. I looked at we were at Stargate, of course, and it was dark outside, and we had an open house. And when you look at the trees with it, and you know you know some thin clouds that are barely visible, it really brings things out, almost like a night vision effect. It was really surprising to see that.
yeah, well, it is a night vision effect. You are collecting more light.
Yeah. Mm-hmm.
I mean, I once drove home, as I pulled into my garage, as my headlights flicked across the lawn, I saw something move out in my backyard. And I live kind of in the country. So I parked the car and it's dark, right? I step out of the garage and what is it? And I can faintly see something is out there. So I keep back then I kept a pair of 10 by 50 binoculars in my back of my car. So I just grabbed them and it was amazing how much brighter the image looked because binoculars gather more light. There's a skunk rolling around and playing with something in the backyard. I was glad I didn't walk out to see what it was.
Yeah, you think?
But think about it. For the average person, 10 by 50 binoculars collects light over a 50 millimeter diameter. And if their pupil is, to make it simple, 5 millimeters, that's a ratio of 10 squared. You're collecting 100 times more light. 100 times. So I didn't need any magnification. I just needed the 100 times brighter image. So they are night vision binoculars.
Yeah.
And even 2x binoculars
Yeah.
gives you 1.5 magnitudes. That's significant. That's a factor of 3 or more in brightness. I mean, we're all astronomy types. We know that, right? When you look up at stuff through a telescope, it's easy to get aperture fever.
Yeah.
Right? Because you can
Right,
see dimmer
right.
things.
The surprising thing about it was that it's almost like at the same magnification, a little bit more, than with your own eye, only brighter. So that was the thing that was different about it. Not like when you look through a 10 by 50 binoculars where you get a lot more magnification than with your eye. So that was kind of interesting.
I know exactly what you're saying. It's a different experience. It is not like 10x binoculars. It's something else again in between that and no binoculars at all.
Right.
It's like supervision.
Yeah, it is.
And it's a different experience during the daytime when you don't need extra amplification of light. At night, you get amplification and you can see dimmer things. So, like I said at the beginning, I don't recommend anybody get 2x binoculars as their only binoculars. You need a pair of 7 to 10x or higher mag binoculars, but there's a place for these 2x binoculars, either to own them or have a friend who has a pair, or now an observatory that has a pair. So,
any other questions for Dale or comments? I do have a comment. We bought my granddaughter a pair of binoculars, right? These little tiny things, and she picked them up and was able to use them immediately. I could not believe it. So I have not given her these 2Xs, but I'd like to see her reaction to those.
the obvious thing to say is be careful.
Oh yeah, here, don't look at that bright thing. Nope,
Look
nope,
at that
nope.
bright thing, right?
I mean, kids can forget, and it's so quick, and bam,
Yep.
both eyes.
I'm very aware of that when she has those binoculars. I'm always like, don't be
Yeah,
looking
I'm
at the
saying that
window.
largely for the benefit of the whole group. Some people might not think about it. You mean following a bird or an airplane, and then bam.
Ow.
I always give people the illustration of what you can do with a magnifying glass when you focus sunlight. You can set something on fire.
Set something on fire, right?
You don't want to do that with your eyes.
No.
Because it won't hurt either.
Well, for an instant it will.
Well, it's certainly not fast enough. It won't hurt.
Yeah, right.
Okay, well, if there's no further questions, I'm going to wrap this meeting up. Thank you, Dr. Dale, very much. Our next meeting will be in person at Cranbrook on Monday, June 6th. So see everyone there. Unfortunately, we won't be going out for gastronomy after this. So
Coney Island will have to wait again.
yeah, next month.
Maybe.
All right. So with that, good night, everyone.
Good night.
Good night.
Thanks, Dale.
Good night.
night.
Next presentation.